My name is Hubert Hasenauer. I'm here the professor for forest ecosystem management. And forestry or forest management has a very strong connection to forest companies. So lots of our projects are often initiated by forest companies or forest organizations where they are interested in special problems or problem-solving potential. And therefore our research is also strongly driven to find solutions or real-world solutions for forestry problems. Mm-hmm. Well, the added value is that scientists think about problems and try to find solutions. And companies use these techniques or these solutions to implement them for real-world problems. And for us, the real-world application is always something like an evaluation if our concepts or our theories work in practice. And therefore this cooperation between, let's say, science or universities and companies is extremely important for our research. Mm-hmm. Well, there are great challenges, and the great challenge is often that companies are driven by specific, let's say, expectations. And in research, you never know what will be the result. A CEO of a company has a problem and expects a solution within a given time. And this is exactly what universities cannot guarantee. Because we do research, and with research you never know what will be the result. You can find a solution, but you may also fail. And this is often the challenge. And then another problem is that companies often underestimate the effort it takes to produce new know-how. And there is a good saying in that you say, what is the difference between research and innovation? And my solution would be, research needs money to produce know-how, and innovation needs know-how to make money. And these are a two-step procedure, and this is what we often face in our research. Well, we are here at the University of Natural Resources and Life Sciences in Vienna, and BOKU, as we call this with a shortcut or acronym in German, is famous for its specific structure in our bachelor and master programs. So all our programs are set up in a way that we have, let's say, a natural science component, a technical component, and a socio-economic component. And this makes us extremely strong in training and our students in problem-solving options or potentials. And therefore our students are very well prepared for real-world problems. And this is very different to the educational programs of other universities where you usually work in one sector. And if you relate this to remote sensing techniques and so on, so this would be a technical issue. And the technical issue comes in through, of course, mathematics, but then special training courses which are included in every study program. Of course, the students have then the opportunity to specialize in their fields where they get an additional courses, but the minimum number in these 3 pillars, as we call this, is obligatory for each student here at BOKU. Okay, remote sensing technology is an emerging field which is extremely important for a lot of natural science fields, including silviculture or forest ecosystem management. If we consider that we can't measure every tree on Earth, or it's still extremely costly to do these typical forest inventory designs, the remote sensing techniques have provided us a tool to get some rough estimates across larger areas. And we here at the Institute of Silviculture work since, well, almost more than 10 years with the famous MODIS product developed by the NASA Earth Science Center in the United States, where they developed an algorithm to predict the productivity on Earth on a certain grid size for all types of vegetation. As foresters, we are of course interested only on forest areas, and our research was really dedicated over the last years to combine this with terrestrial data to get better estimates and then use this for carbon cycle assessment. So we developed, for example, carbon cycle estimates and carbon cycle models for Europe based on a combination of terrestrial data and remote sensing data. And with this strategy, we were extremely successful. Well, I'm convinced that this is a growing area for two reasons. First of all, it's one of the basic inputs if we further develop the digitalization. Because digitalization by itself is something which, everybody talks about digitalization, but what is it? So you need to have an application case where you can improve the techniques, where you might be able to bring certain methods on a different level to get a better insight in information, and you will need input data. And one of the input data producer will be remote sensing technologies or radar technologies or whatever. So, well, let's put it this way, remote sensing or airborne techniques in a broader sense are just input data. But the real interesting challenge is, what do we do with the input data and how do we make sense out of it? Just to have the data doesn't mean that I have an information. You could even be overwhelmed by this information. So therefore, the future I see is that we find smart tools to segregate from this enormous amount of information, the information we need, whatever this means. So therefore, I'm convinced that this will play a major role in the future. And in combination with this, we will have to deal with the question of big data. What does this mean? We will have to talk about computer capacities. So how do we organize this? And then last but not least, all these techniques are just input for, let's say, solving real-world problems. So at the end of the day, we will have to ask the question, what real-world problem have we solved, or what do we have improved by doing this? And this is often then the most difficult part, because all these data options and all the techniques should not become a playground. If we look back in the history of remote sensing techniques, then a milestone was that the NASA launched a so-called Mission Earth program in the 90s, where they explicitly designed satellites for monitoring environmental behavior. And these satellites are running now for almost 15 to 20 years. It depends when they were launched. And we see that after a certain time, of course, these satellites are outdated, and the next generation of satellites pops up or has to be developed. And here Europe is really leading. They have developed, based on the experience from the NASA Mission Earth program, some excellent satellites. But the key problem here is always the availability of data. And the big success of the NASA Mission Earth program, where, for example, this MODIS data and other environmental data were developed, was the free access to information. With this free access to information, you initiate research, you initiate then also companies who use this data for practical real-world applications. And if you make data limitations, you basically ruin the innovation. And this is a key problem often in these kind of developments. On the other hand, I think it's important to mention that these data are often financed by the taxpayer. And if a taxpayer pays for the development, then it should be freely available to everybody. because the basic idea, and we come back, what is the idea of universities or research, is to develop know-how so that society can improve or that society has a benefit.
Yeah, my name is Tamara Eckert. I'm a researcher at the Institute of Silviculture here at BOKU, the University of Applied Life Sciences. And I recently finished my PhD work here successfully. And yeah, my experience with GIS and remote sensing data, we worked in a project together with many forest companies and organizations where we get a strong connection and a joint research activities where different research questions were formulated together. And an important aim was to generate maps of forest stem productivity of an important non-native tree species, and therefore I basically used the GIS software to generate these maps. It was about Douglas fir cultivation in Central Europe and its importance under changing climate. And yeah, the project was mainly launched as there are many secondary coniferous tree forests established with Norway spruce, which is not very drought resistant, and therefore there's a need to find an alternative. And one option is planting an alternative tree species, namely the Douglas fir. Yeah. Yeah, we worked. It's called the Douglas fir project. The Douglas fir is an important alternative tree species in Europe, as it is more drought resistant compared to other native tree species. Therefore, there's a high interest and high demand in this tree species, especially from forest practitioners. And based on that interest, we initiated this project. And an important question is the site suitability of such a tree species. And therefore, we investigated many different sites in Central Europe and created a prediction function. And it's always important to get this information into space. So we used this prediction function and used many input data provided by the European soil database in order to be able to generate these maps and do the spatial analysis. I used statistical programs, the R environment, from their different packages, and the GIS was mainly used for the visualization of the data, yeah, and for the maps. There was a very strong cooperation, so we worked together with more than 20 private forest companies, and this was a very important interaction and also network to really get some research questions from the practical side. And yeah, that was important. There were some challenges. I mean, it's yeah, always the expectations and what can be solved in research, what is able. Yeah, there's always a mismatch. So therefore, it's very useful to have many meetings and yeah, and you always you have to communicate in a way that also the forest practitioners are able to understand it, and yeah, so the communication is very important. So then you can solve many problems. And the the main output of these maps is that foresters are now able, okay, they see, here's the map, where is my forest area and what is the potential of this non-native tree species there. So that's really the application of the informations we generated during this project. Based on the education you get at the university and what is then finally needed in practice, I mean, there are some obstacles, and I think that's true for different fields of sciences and methods you use, and therefore it's always important to get some help from others, from other employees, and I think that's important in order to be successful. You study at university and you have a lot of different courses, study a lot about different methods, and then when it comes into application, it's always there are these obstacles. But here at BOKU there are many practical work during these courses, so you have to work together with some students and on a project, so you really have to apply what you learn there, so you are rather good prepared, and also it always depends on the working environment at the institute. So here at our institute it's very good that you have many employees you can ask for special problems, and then normally you are able to solve it and get your results. It's important to know where to get the data, the resolution of the data, so you really have to check if this data can be applied to really solve your research question. And it's just important to start with it, and then you will see, okay, what are the obstacles, and